So the slide is visible, right? Slide ki dekhte paccho? Slide.
Yes, sir.
Yeah,
Yes,
thank you.
sir.
So today we're going to study motion in 2 and 3 dimension. Actually, in our last class, we studied motion in 1 dimension. Actually, motion in 1 dimension means an object is traveling in so 1D motion means object is traveling in a line, for example. Maybe this is the x-axis, an object is traveling along x direction only. So this is 1 dimensional motion. 2 dimension means if you consider 2 axes like x and y, x-axis and y-axis, and an object is traveling this way. Okay, so in this case, the motion is 2-dimensional motion. That means the motion at every point, it has 2 components. One is x component, the other one is y component. So this is 2-dimensional motion, and basically the space is 3 dimension. So motion is mostly motion or 3-dimensional motion. So now let's see how the different quantities related to motion are defined in case of 2-dimensional or 3-dimensional motion. So let's think a 2-dimensional space. Let's consider a 2-dimensional space. Let's take a nucleus first. Okay. And then let's think an object is moving in a 2-dimensional space. This is a 2-dimensional space. Okay. 2-dimensional space. This is the x-axis, and this is my y-axis. And initially, the position of the object was here. Okay. And its displacement is like this. R is the position vector of the object. Okay, R is the position, or say R1. Okay? R1 is the position vector of an object initially. Okay? So R1 is defined as, how to define R1? You can see like the component of R1 along x direction is x1, for example, and along y direction it is y2. So initially you can say R1 equal to x1i plus y1j, right? Okay, because R1 has an x component of x1 and y component of y1. And think, let's say after this is at time 0 second, and at time t second, after time t second, the object is moving and it is here, for example. Yeah. And the position for this point is R2. The position vector for this point is R2. So if I want to write R2, R2 is basically let's say x component of R2 is x2 and y component of R2 is, oh, sorry, this one is y1. Y component of R2 is y2. So R2 can be written as x2i plus y2j. Okay, so this is R2. Now the displacement, how should be the displacement? The displacement is what? Displacement is just equal to the difference in position. Difference in position, or we can say, okay, final position minus initial position. So I can write the displacement as delta R. Let's say the displacement is delta R. It is defined as R2 minus R1. This is the vector quantity. So displacement is R2 minus R1. So I can write displacement vector R is equal to R2 is this guy, x2 and I plus y2j minus x1i plus y1j. Okay, and that is, I am subtracting two vector. When we are subtracting two vector, what we did? Actually, we subtract the like component, that is x component divided by minus x component. That should be like x2 minus x1 into I plus y2 minus y1 into j. So this R is my displacement. This is the expression for displacement. Okay, this is the expression for displacement for an object traveling in a 2-dimensional space. And same again, we can define the velocity. Now the velocity is defined as velocity let's say velocity is v. V is defined as what? Velocity means displacement over time. When displacement is delta r and time is t, let's say time is delta t, time is delta t. Let's say initially it was time was t1 and final time was t2. So the time difference is t2 minus t1. Okay, and t2 minus t1 is delta t. So my velocity means displacement divided by time. Total displacement divided by total time. By the way, this is average velocity. This is called average velocity. Average velocity means total displacement over total time. That means, oh, by the way, here I can write one thing else again. Delta r is equal to x2 minus x1. That can be written as delta x. Delta xi plus y2 minus y1 equal to delta y. That can be written as difference in y, delta yz. So delta r by delta t is basically equal to delta xi plus delta yj plus delta t, and this can be written as delta x over delta ti plus delta y by same component delta t into j. And then V average can be written as delta x by delta t. What is that? This is the velocity. This is again velocity, but this is the average velocity along x direction. This is the velocity, average velocity along x direction. So we can write this as f average x component of average velocity I plus, this is basically delta y by delta t. This is again average velocity, but it is along y direction. So this can be written as the average y and j. Okay, so this is the expression for velocity. This is the expression for average velocity in 2 dimension. This is the expression for average velocity in 2 dimension. And actually, we know there exists 2 types of velocity. One is average velocity, and the next one is instantaneous velocity. The next one is instantaneous velocity. Let's say how to find out the instantaneous velocity. So instantaneous velocity is basically defined as v, that is equal to dr over dt. In 1D it was dx over dt. That means ddt of displacement, or of position, ddt of position vector. So position in 1D position was x, but in 2D or 3D the position vector is r. So v equal to ddt of r. That means ddt of my position vector is, I can write xi plus yj. And let's say if I write it in 3D, with 3D to rekhi that in case of 3-dimensional vector, my third component z is k is the unit vector. Okay, so velocity can be written as, so I can write a dx over dti plus same component dy by dt j plus dz over dt k. So basically v, again dx over dt, this is what? This is the velocity, instantaneous velocity along x direction, or we can write this as x component of instantaneous velocity plus dy by dt j. This is basically y component of velocity times j plus dz by dt equal to vzk. Okay. So this is the velocity vector in 3D. The 2D thake thale I have to remove just one maybe from here. So this is a important expression. And same again, we can also write an expression for instantaneous acceleration. We know that instantaneous acceleration A is defined as ddt of v. ddt of v, that means it is equal to ddt of v, velocity vector v means this one. This is my velocity vector v. So this can be written as vxi plus vyj plus vzk. And this is basically equal to dvx over dt I plus dvy over dtj plus dvz over dtk. Okay. And again, dvx or dt is basically acceleration, and this is the acceleration along x direction. So we can write a equal to x component of acceleration times I plus same again dvy by dt, which is acceleration along y direction, a y times j plus z component of acceleration, so a z k. So this is what the acceleration is. This is the acceleration. This is again the expression for acceleration in 3D. Okay, so in today's lecture, we are going to use this two actually relation to find out the expression for velocity and acceleration. So here these things are discussed actually. I'll move. Let's try a math now. Let's try some math that will clear our concept. So this math is about a rabbit run. A rabbit runs across a parking lot on which a set of coordinate axes has strangely enough been drawn. The coordinate of the rabbit's position as a function of time are given by, this is x equal to 0.31 t square plus 7.2 t plus 28, and y equal to 0.22 t square minus 9.1 t plus 13. So a rabbit is running on a parking lot, and its position দেখো এটা যদি টু ডাইমেনশনাল স্পেস হয় এর পজিশনটাকে আমরা কি করতে পারি x আর y কোঅর্ডিনেট দিয়ে ডিফাইন করতে পারি, and this position are function of time like this. Okay, that are given in these two equations. What I have to do at time t equal to 15 seconds, what is the position vector r in unit vector notation and in magnitude angle notation? So what I have to find to help, I have to find out the radius vector, position vector r of the rabbit in unit vector notation. Two notation I have to use. One is unit vector notation, and the second is magnitude angle notation. So let's see what does unit vector notation means and what is magnitude angle notation means. Let's try what is unit vector notation. If you write a vector using unit vector, that's are called unit vector notation. So we can write the unit vector in unit vector notation r equal to xi plus yj. Okay, this is the position vector at unit vector notation. Okay, it's a position vector hobe in unit vector notation. Now I have to find out the position vector when time t equal to 15 seconds. যখন time 15 seconds তখন এই r এর ভ্যালু ফিগার আউট করতে হবে। তার মানে time t equal, at first I have to find out what is the value of x when t equal to 15 and what is the value of y when t equal to 15, and substitute these values here. Okay, so at t equal to 15 seconds, x equal to what? X equal to minus 0.31 t square plus 7.2 t plus 28, and y is basically equal to, oh no, I don't need to write y first. So let's write it here. So it would be like 0.31 into 15 whole square plus 72 into 15 plus 28. Can you guys tell me what is the value? Can you calculate this value for me, please? Anyone?
66.5. 66.5.
66.25. Okay, 66.25 is in meter. And y, same again, for y I have to replace again t equal to 15, as I want to know the value of y at 15 seconds. So this would be like 0.22 into 15 whole square minus 9.1 into 15 and plus 30. What is the value again for y? Y, value of y একটু বলবে? বলতে পারবে না কেউ? ক্যালকুলেটর নেই কারোর কাছে?
স্যার -66 আসছে।
Same again, -66.
Yes sir. Sir,
0.22
I'm calculating it again.
0.22 into 15 is -66, right? আর এটা ছিল plus 66.25. Acha, this one I made a mistake. My bad. I made a mistake. This is not actually 72. This should be like 7.2. This one should be like 7.2 into 15. Oh, my bad. Can you calculate it again for me, please? This one. This is 66, right? No, this is 66, and this one is, I guess, value of x is what? বলতে পারবে? Okay, let me try by myself. পারোনি কেউ ক্যালকুলেট করতে তোমরা? X is 66 and y is minus 57. Okay. X is 66 and y is minus 57. Okay. X is 66 and y is minus 57 anyway. So this is these are the x and y coordinate. I have to substitute the value of x and y here, and this will give me the value of r equal to 66i minus 57j. Okay, so this is the position of the rabbit in unit vector notation. And then they are also asking me one more thing, that is I have to find the position in magnitude angle notation. What is magnitude angle notation? The magnitude angle notation, actually I have to, if a vector is given to me, let's say vector is given to me, what I have to tell? I have to tell the magnitude of the vector, okay, the magnitude of the vector, and the angle that the vector makes with x direction, and the angle x direction এর সাথে যে অ্যাঙ্গেলটা মেট করে সেটা আমাকে ফিগার বলতে হবে। So magnitude, since this is my vector 66i minus 57j, so I can easily find out the magnitude of the vector r. Magnitude of this vector means x component is square plus y component is square. 66 square plus minus 57 whole square. And if you calculate this thing, it will give you 87. This will be 87 meter. And also I have to find out angle theta. So if the angle that rabbit makes with x direction, if it is theta, then we can write tan theta is basically equal to y component divided by x component. My y component is minus 57 and x component is 66. And this is basically equal to tan 41 minus 41 degree. Okay, or I can say theta equal to minus 41 degree. Okay, so the angle that it makes with x direction is minus 41 degree. Now my question is, what does 41 degree means? 41 degree minus 41 বলতে কি বোঝাচ্ছে? Plus angle minus angle, এটা কি আমরা বলেছি কখনো? Not class. So usually the angle is measured in clockwise direction from x-axis. Okay. Sorry, counterclockwise direction. If this is my x direction, and if I measuring in this way, then we can say the angle is positive. But if you measure counterclockwise, then it is negative. Sorry, clockwise. So minus 41 means I have to measure in a clockwise direction. That means this way. So minus 41 means you have to go clockwise by 41 degrees. So if this is my 41 degree, then we can say, okay, this is the position. Okay, let's see here, and this is the position of the object. And this value of r is equal to 83. Okay, clear? So this is one math. তোমরা কি আমার কথা শুনতে পাচ্ছ?
Yes, sir.
Yes, sir.
Yes, sir.
ঠিক আছে, thank you. Anyway, so এটা তো আমরা ডিসকাস করেছি already. Let's try one more math. That is for the rabbit, same rabbit. For the same rabbit, we have to find the velocity find the velocity of the rabbit at time t equal to 15 seconds. What I have to do, I have to find the velocity of the rabbit at time t equal to 15 seconds. So I'm taking niye ashlam because this gives us the position vector. Okay, so the same rabbit who has the position vector x and y, whose position are function of time given here. What I have to do, I have to find out the velocity. I have to find out the velocity at time t equal to 15 seconds. Now, same again, the velocity, for velocity, we know the velocity vector is defined as, is defined as Vxi plus Vyj. Vxi plus Vyj. Now, here Vx is what? Here Vx is basically equal to what? Dx over dt. Vx means dx over dt. So that means the dt of minus 0.31 t square plus 7.2 t plus 28. And this is basically, I have to differentiate this guy with respect to time. So this will give me minus 0.62 t plus 7.2. Clear? Is that okay? Differentiation to jano shobai naki?
Yes, sir.
Okay.
Yes,
And then Vy is equal to dy by dt. That means what I have to do, I have to differentiate this y with respect to time. That is the dt of 0.22 t square minus 9.1 t plus 30. So that means this is equal to, so I have to multiply this by 2, 0.44 t minus 9.1. And now they are asking for what? They are asking for the velocity at time t equal to 15 seconds. So at t equal to 15 seconds, my Vx will be equal to minus 0.62 times 15 plus 7.2, and Vy is equal to 0.44 into 15 minus 9.1. Minus 9.1. So can you calculate this value for me, please?
Sir, Gx is equal to minus 2.1.
And Vy?
Sir, I'm doing it.
Our presentation chole geche, sorry. Sorry, guys. Can you see a slide now? Slide ki dekhte paccho?
Yes, sir.
But chole geche. Jai hok, ami bolte pari. Let me write it once again for you guys. Helpful hobe. V is equal to Vxi plus Vyj, and then Vx equal to dx over dt, which is basically equal to minus 0.62 t square plus 7.2, and Vy is equal to 0.44 t minus 9.1, and at t equal to 15 seconds, Vx is equal to what? I have to replace t by 15, that is minus 2.2, right?
Sir, ওখানে t square হবে না, t হবে শুধু।
Yes,
Vx,
t,
yes,
okay.
sir.
Vx would be what? T point 2 point?
Minus 2.1.
Minus 2.1, and what about Vy?
Minus 2.5.
Minus 2.5. What I have to do, I have to replace the value of t by 15. Put t here. So then finally we can say then V equal to minus 2.1 I minus 2.5 J. Okay. And This is the velocity. এখন আমার একটা কোশ্চেন আছে যে what will happen, like is it possible to do this math initially by replacing t by 15? আমি কি শুরুতে t এর জায়গায় 15 বসিয়ে তারপরে কি ডিফারেন্সিয়েট করলে কি ম্যাথটার অ্যানসার পাবো? Like what I did here, just have a look. At first I differentiate x with respect to time, x with respect to time, and then we replace t equal to 15. আমি যদি এরকম করি, if I replace t by t equal to 15 first, আমি answer পাবো না, because then in that case there is no dependence, there is no t dependence, it will be just a number, so I cannot differentiate it. So this is how we have to do it. And there was another math that is asking us, actually পরে আসে সেটা একটু করে নিই, so that is asking us to find out the, for the same rabbit we have to find out the acceleration at time t equal to 15 seconds. For the same rabbit, find out the acceleration at time t equal to 15 seconds. So now for that rabbit, we know acceleration is equal to what? Equal to axi plus ayj, right? And my acceleration is basically equal to what? Acceleration is basically dvx over dt. And what we find in our previous example is that vx is basically equal to minus 6.62 t plus 7.2. So this is minus 0.62 t plus 7.2. And if we differentiate this thing, I'm going to get, oh, this is my ax, by the way, ax equals to dvx by dt. And by differentiating this will give me 0.62. Okay, and same again, ay is equal to differentiation of vy with respect to time, that is d dt of dy is what? Vy is minus 0.44t, 0.44t minus 9.1. 0.44t minus 9.1. So this is basically 0.44. So at time t equal to 15 seconds, what should be my ax? Ax ki hobe t equal to 15 seconds. What should be the ax at time t equal to 15 seconds? There is no time dependence here. So same is constant. So 0.62. Okay, ax. Ax is independent of time. That is at any time. In 0 second, 5 second, 10 seconds. So ax etai thakbe. And same again for ay, it is constant, independent of time. So at time t equal to 15 seconds, it is 0.44. So at t equal to 15 seconds, my acceleration is equal to minus 0.62i plus 0.44 j. Okay, so this is the expression for acceleration. At this point, I want to try a few more maths. For example, number 1. This is easy one. This is the easy one. So I don't want to do this one. It's very easy. Try this one. Number 6. An electron's position is given by r equal to 3i minus 4j plus 2k. But t is in meters. It's very easy math. In unit vector notation, what I have to find out, what is the vectors, what is the velocity of the electron at time t equal to 2 seconds. Okay. So what I have to find at time t equal to 2 seconds, I have to find out the velocity. এটা কি তোমরা করতে পারবে ম্যাথটা? একটু ট্রাই করবে? Yes. নাকি আমাকে করতে হবে? At time t equal to 2 seconds, what is the velocity v? So velocity v here is basically equal to, velocity is dr by dt. This is the expression for velocity. Velocity means dr over dt. So my velocity will be equal to, one thing you can do, like you can differentiate d dt, that is r is equal to, r is given 3ti minus 4t squared j plus 2k, right? So 3ti minus 4t squared j plus 2k. So differentiating it will give me t with respect to 3t with respect to time will give me 3i minus 4t squared, that would be 8tj This should be 8tj, right? 8tj.
Yes, sir.
8tj. And if we differentiate 2 with respect to time, this will be 0. So plus 0 dot k. Basically, 0k means 0. I don't worry about this thing. So my velocity of Vt equal 3I plus minus 8tj. So at time t equal to 2 seconds, V of t is equal to 3I minus 8 into replace t by 2. Okay, that is equal to 3I minus 16j. This is my velocity as a function of time. This is my equation math 1. And in B, what they're asking me, what is the velocity in unit vector notation? Okay, it is the column. What is V? In unit vector notation, this is okay. The oh, now এখানে দুটো part ছিল একটু খেয়াল করো first one is what is the in unit vector notation, what is the electron's velocity, what is the electron velocity? This means this is the generic velocity, this is the generic velocity. That means in unit vector notation, generic velocity, there is time dependent velocity. Okay, that is this one. This is my part A. A is complete here. A is completed here. In A, they are just asking for the velocity, generic velocity. And in part B, they are asking me the velocity at time t equal to 2 seconds. So this is my part B. And in part C, they are asking me the magnitude of angle at time t equal to 2 seconds. At time t equal to 2 seconds, what is the magnitude and what is the angle relative to positive x direction? So magnitude of velocity V at t equal to 2 seconds is, we know, x component square plus y component square. That is 3 square plus minus 16 whole square. I left this calculation for you guys. And number D, what is the angle relative to the positive direction of x-axis? What is the angle relative to the positive direction of x-axis? We know theta equal to what? Tan inverse y component by x component, that is minus 16 over 3. আমরা এটা খুব ভালোই জানি, তাই না? If a vector makes an angle, let's say A, it makes an angle theta with the positive x direction. This is x direction, this is y direction. আমরা জানি যে x component ax equal to a cosine theta and y component is ay, that is equal to a sine theta. I already discussed it, I think, in the first class. So ay by x equal to tan theta. That means theta equal to tan inverse ay by ax. Okay. So আমার যে ভেক্টরটা আছে তার y component এবং x component কে ডিভাইড করে তার tan inverse যদি আমি করি, that will give me the angle. Is it okay, guys? Clear matter?
Yes, sir.
So
Yes, sir.
if ji কেউ কিছু বলবে? So if similar kind of math appears in the midterm, I think তোমরা করতে পারবে না?
Yes, sir.
করতে হবে ইনশাআল্লাহ, প্র্যাকটিস করতে হবে, একটু করতে হবে। Okay, let's try another math, math number 11. The position vector r of a particle moving in xy plane is given by this I plus 6 minus 7 t to the power 4j, where r is in meter, t is in second. What I have to find in unit vector notation, calculate r, v, and a for time t equal to 2 seconds. What I have to do, I have to find out the position vector, velocity, and acceleration at time t equal to 2 seconds. Okay, this is really very easy math. এটা কি আমার পড়ার দরকার আছে না পারবা তোমরা? পারবা না এটা করতে? আমি একটু বলে দেই hints. r equal to ছিল 2t cube minus 5i plus 6 minus 7 t to the power 4j. Okay, this is my r. তাহলে how do I have to find r at time t equal to 2 seconds? r equal to কি হবে? You just have to replace t by 2 seconds. 2 cube minus 5i plus 6 minus 7 2 to the power 4j. Okay, this is my position vector. Clear? This is r. And to find the velocity, part B, I have to find the velocity at t equal to 2 seconds. So velocity is basically what? Sorry, আমার নেটটা আবার চলে গেছে তাই না এইটা স্লাইড?
শেয়ারিংটা অফ হয়ে গেছে।
Yes, sir.
টুডে অ্যাকচুয়ালি এইটা একটু সমস্যা করছে আজকে। এনিওয়ে চলে আসতেছে। সো দেখতে পাচ্ছ?
জি স্যার। Yes, sir.
Okay. So now here is a thing. Let's do it again. Velocity, right? So velocity means what? Velocity means dr over dt, right? That means I have to differentiate this thing with respect to times. So that is the dt of 2t cube minus 5i 6 minus 7 to the power 4 j, right? So basically velocity will be equal to 6t square 5 to 0 8 I minus 28 t cube. I think all of you are familiar with differentiation, so you know how to differentiate these things. Okay, so this is the velocity, and at time t equal to 2 at time t equal to 2 seconds, my velocity will be, what I have to do, I have to just replace t by 2, that is 6 into 2 square I minus 28 into 2 cube j. So I left this calculation for you guys. তোমার বাসায় যে try করো, আমি এটা complete করছি না. So you have to use the calculator. And same again for the acceleration. For the acceleration, what I have to do, acceleration means what? Acceleration means dv by dt. So what I have to do, I have to differentiate this guy. So acceleration is basically equal to d dt of 6t square I minus 28 28t to the power 3j. So acceleration will be 12t I minus 3 times 28. That will be like 84t square j. Okay, and then this is the expression for acceleration. And for to find the value of acceleration at t equal to 2 seconds, you have to replace t by 2. Just replace t. So I'm not going to do the rest of the part. I think you will be able to do this. পারবা না এটা করতে? পেরে যাবে।
Yes, sir.
Okay, and then let's try another one. So much শেষ হয়ে যাচ্ছে। So let's try another math. A proton. Okay. A proton initially has velocity 4i minus 2j plus 3k, and then 4 seconds later its velocity is minus 2i minus 2j plus 5k. Find out for 4 seconds what are the proton's average acceleration in unit vector notation, and the magnitude of average acceleration, and the position and the positive direction of x-axis. আমাকে কি করতে হবে? What is given? A proton, there was a proton, its initial velocity was this, the first one, and after 4 seconds, this is the velocity. So initial velocity and final velocity they are there, and time is also given. What I have to find? I have to find the average acceleration. So average acceleration is basically equal to acceleration average is basically, we know, delta v divided by delta t. That means difference in velocity by difference in time. So here delta v means what? Delta v means final velocity minus initial velocity, যেটা আমরা normally লিখে থাকি final velocity. Final velocity কোনটা? Initial, which one is my initial velocity? This is my initial velocity, right? A proton initially has this velocity, and after 4 seconds the velocity is this one, so this is my final velocity. So initial velocity means 4i minus 2j plus 3k, and final velocity is what? Final velocity is this one. So we can write here final velocity minus initial velocity. So final velocity is minus 2i minus 2j plus 5k. This is my final velocity minus initial velocity is this one, 4i minus 2j plus 3k. So delta v basically will be equal to this one minus this one. So minus 2 minus 4, that is equal to minus 6i. And then I have to subtract j by j. So this is minus 2j and this one is minus 2j. Minus 1 is plus 2j, this will be 0. And 5k minus 3k, that's equal to 2k. Is subtraction ta korte parbe na tumra? Is it easy or difficult? What do you think? আমরা subtraction of value vector আমরা জানি, right? Okay, yes, পারবে তোমরা, আমি জানি। And our del t is what? Del t equal to 4/7. So just simply just replace this value here, minus 6i plus 2k divided by 4. So average acceleration is basically equal to minus 6 by 4 I plus 2 by 4. Okay. I have to replace, I have to put cap sign here. So this is the average acceleration. Okay. These are vector sign. Vector sign here. Okay, so this is the average acceleration part A. And here you see I can write this like 1.5i plus 0.5k. So this is my average acceleration, okay? But এখন if the average acceleration is given, average acceleration যদি বলা থাকে, তোমরা কি ম্যাগনিটিউড বের করতে পারবে না? পারবে? I think পারবে. And it is also possible to measure the angle using the same formulas. Okay, so square root of a square, this square plus this one square, এটা দিবে values magnitude, and angle is y component or z component by x component. Let's write the last math, I guess. That's the last math of the day. A particle leaves the origin. It is a tricky math. A particle leaves the origin with an initial speed of v equal to 3i and a constant acceleration of 1i minus 5j meter per second. When it reaches its maximum of x coordinate, what are the velocity and the position vector? What are the velocity and position vector? So, velocity of a particle is given. This is the velocity, and it has a constant acceleration 1i minus 1i minus 5j. এখন বলছে when the particle reaches maximum of its x coordinate. Yeah, it's like অবজেক্টটা যখন ট্রাভেল করে, যখন তার x কোঅর্ডিনেটের ম্যাক্সিমামে যে পৌঁছায়, এটা মেবি x কোঅর্ডিনেটের
ম্যাক্সিমামের ভেলোসিটি 0 হয়, এটা
ভেলোসিটি 0 হয়। হ্যাঁ, সো এই পয়েন্টটাতে x কোঅর্ডিনেট যখন পৌঁছায়, তখন what is the value of y coordinate then? তখন what are the velocity and the position vector? অর্থাৎ ম্যাক্সিমাম অর্ডিনেট যখন পৌঁছাচ্ছে, আমি আবার একটু সুন্দর করে ড্র করার চেষ্টা করি। So let's say this is my x-axis and this is my y-axis. An object is traveling like this. And this is his maximum of x coordinate. Okay, this is maximum of x coordinate. এটা এখন এই maximum of x coordinate যখন পৌঁছাচ্ছে, তখন what is this velocity? What is this velocity at this point? And what is the position vector r? What is the position vector r here? এই পয়েন্টে maximum of x coordinate position vectorটা কি হবে and velocity vectorটা কি হবে? Okay, এখন to do this math, actually we need to before doing this math, আমাদের কিছু theory জানতে হবে. We need to know some theory. What is the theory? যখন when an object is traveling in 2 dimension or 3 dimension, আমি নতুন একটা পেজ নিয়ে আসি, মনে হয় না আজকে ম্যাথটা শেষ করতে পারো, বাট এই ডিসকাশনটা একটু করে দেই। When an object is traveling in 2D or 3D, let's say 2D, travel 2D. This is my x direction and this is my y direction, and an object is moving here. এখন যখন এই অবজেক্টটা মুভ করে, প্রতিটা পজিশনে কি হয়, তার একটা পজিশন আছে, x এর পজিশন আছে, y পজিশন আছে, তাই না? প্রত্যেকটা জায়গায় at every time তার একটা পজিশন এবং x পজিশনের x কোঅর্ডিনেট y কোঅর্ডিনেট আছে একইভাবে তার যদি ভেলোসিটি তুমি নাও ভেলোসিটিরও একটা x কোঅর্ডিনেট থাকবে ভেলোসিটির একটা y কোঅর্ডিনেট থাকবে and same again for acceleration should have a y component and a x component and see here in this case x component and y component are independent to each other x component y component উপর ডিপেন্ড করে না এবং ভেলোসিটি আর অ্যাক্সিলারেশনের x কম্পোনেন্ট y কম্পোনেন্টের উপর ডিপেন্ড করে না প্রত্যেককে ইন্ডিপেন্ডেন্ট ক্লিয়ার প্রত্যেককে ইন্ডিপেন্ডেন্ট এখন তাহলে ইকুয়েশন অফ মোশন গুলো কি হয় আমি একটু এখানে একটু লিখতে চাই ইন 1D তে আমরা কিছু ইকুয়েশন দেখেছিলাম যে v let's say final velocity let's say initial একটা অবজেক্টের ইনিশিয়াল ভেলোসিটি ছিল v0 and its after time t its velocity become v তাহলে আমরা জানি in one dimension we can write v equal to v0 plus at right লিখতে পারি and then one dimensional case and আমরা লিখতে পারি displacement x equal to v0 t plus 1/2 at square right এটা লিখি না and v square equal to v0 square plus 2ax লিখতে পারি এগুলো এই ইকুয়েশনগুলো আমরা জানি না আমরা বলি v equal to u plus at s equal to ut plus half at square এখানে u মানে v0 u মানে আসলে v0 u মানে v0 টা লিখছি আর x মানে s এর উপরে ওয়ান ডাইমেনশনাল কেস বাট যখন একটা অবজেক্ট 2D তে ট্রাভেল করে তখন দেখো তার যে ভেলোসিটি আছে ইন 2D velocity has two components. Initial velocity has two components. One is along y-axis, that is vy, and the one is along x direction, that is vx. Akibhabe, acceleration has two components. One is along x direction, that is ax, and the one is along y direction, that is ay. Okay. তাহলে in 2D তে যদি আমি ইকুয়েশন হবে দুই রকমের একটা হচ্ছে x কম্পোনেন্টের জন্য ইকুয়েশন হবে and the other one হবে for y component. Y component. So the equation will be same, but x component equation হবে এক রকমের and y component equation এক রকমের হবে। যেমন v এর ক্ষেত্রে আমাদের তাহলে কি হবে? v এর একটা x component থাকবে, v এর একটা y component থাকবে, that is final velocity. Okay? তো একই রকম ভাবে v0 যেটা ইনিশিয়াল ভেলোসিটি তার একটা x component থাকবে, আমরা যেটাকে বলবো v0 x এবং তার যেটা y component থাকবে সেটাকে আমরা বলবো v0 y। তাহলে x এর জন্য এই ইকুয়েশন পুরোটাই x করে দেব। v0 vx means v0 x plus axt and vy means v0 y, that is velocity y component নিয়ে কাজ করব plus ayt. Same again, x means v0 x t plus 1/2 axt square and v and y equal to v0 yt. Just এখানে v0 টাকে v0 y করে দিচ্ছি y component সময় এবং অ্যাক্সিলারেশনটাকে acceleration y component নিয়ে নিব 1/2 ay t square and in 2D v square means vx square, x component of v square equal to vx component. I have to take x component of this one v0 x square plus 2ax x and same again for vy square equal to v0 y square because v square as y component v0 y square plus 2a acceleration of y component নিতে হবে আমাকে 2ay times y. Clear? So these are the equations. These are the equation for x and y component. আমার যদি 3 dimensional থাকতো তাহলে vz নিয়ে নিতাম। So these are the equation of motion for 2D cases when a particle moving in a 2D space. Okay, so আমরা এইটার ইউজ হয়তো পরের ম্যাথটাতে করতে হবে। তো আমি আজকে এখানেই রাখছি। Let me stop here today. আমরা হয়তো নেক্সট ক্লাসে লাইক ম্যাথটা সলভ করার চেষ্টা করব। Since we are running out of time. Stop the sharing.